Hello everyone, so this is problem number 19 of chapter SHM. So in this question, there are three springs. Let me draw those springs. This is spring 1, and there is a mass attached to all the three springs. Spring 2 is at 90 degree with respect to spring A. So let me write this as A, this as B, and there is one more spring that is at an angle of 45 degree from the horizontal. Now, if this mass M, all the stiffness as K is given in the question. Now it is given that if this mass M is slightly pushed towards this spring C, then what is the time period? So first thing is that if it is hanging somewhere, anywhere, so it will have this, this is the equilibrium position, it is given here, and now it is displaced in this direction. So let me draw. This was the initial position. This was the initial position of the springs. I'm drawing with lines. Now it is displaced slightly here to a distance x. Now this will deform till here. This will deform till here, and it was there here. Now suppose if this distance is x, and if I will draw perpendicular to this line, so this, if x is very small, means negligible, very small distance, then we can say that this length and this length is equal. So this is the elongation in this spring B, and if I draw a perpendicular line from here, so this is the elongation in block A. So now look at this situation. If this is x and this is approximately 45 degree, still if we have changed, you'll see that we have changed this, we have pulled it, so it should not be 45 degree here, because initially it was 45 degree. Now it should not be 45 degree, but it is still 45 degree. It will be slightly lesser than 45 degree. Why? Because this x is very small, so we can consider this as a 45 degree. Now this elongation is, let be x1, or let's say x1. So this we can write that sine 45 degree, sorry, cos. Why? Because this is the hypotenuse and this is, so cos 45 degree is equal to x1 by x. So x1 is equal to x by root 2. Now this is the block mass. Three forces are acting, one along this direction, one along this direction, and one along this direction. So this force is kx1, this force is kx1, this angle is 90 degree, and this force is kx. So resultant of this kx1 is root under 2 kx1 in this direction. So F net, or restoring force, is equal to kx plus root 2 kx1. So it is going to be kx plus root under 2, kx1 is x by root 2. So here we will have 2kx. So basically in entire SHM, what we are doing, this is the force method. What we are doing, that we are giving a slight we are just like giving slight displacement of mass from its mean position, and we are trying to look at the restoring force, and we are wanting to get a restoring force in the form of this, that is F is equal to minus kx. It means the force would be directly proportional to x and it should have a direction opposite to the displacement, then it is called a restoring force, and that is the point in the entire SHM. So that restoring force now we have obtained, and the spring equivalent spring constant we have got as 2k. Now we can say that we have a spring mass system. If we are giving a displacement of x, so we are getting a restoring force that is minus 2kx. So the time period of the system is going to be 2 pi root under m by 2k.